Welcome to Learn Robotics and AI. In this video, I'll be giving you the ultimate robotics career guide, everything that you need to know in order to start learning robotics and establish a career in robotics and artificial intelligence. I'll be giving you several different frameworks, several different tools and ways of thinking that would allow you to make important career decisions. So I'll begin first by talking about specifically who this video is targeted towards. And then after that, I'll give you an honest breakdown of my own personal career path, and I'll give you a breakdown of my decision making process. What was my thought process behind making a transition from mechanical design engineering to robotics, working in startups, working in bigger companies, and now working in research. So why did I make those transitions? What was I thinking? What was my decision making process like? I'd give you my honest view of what led me to make these decisions. Then I'll be giving you an overview of different subdomains in robotics and artificial intelligence. I'll be talking about how you can define your niche. And then I'll talk about several job profiles that you can expect to work in if you want to work in the fields of robotics and artificial intelligence. And then I'll also give you a framework that would allow you to choose a career path based on these job profiles. I'll also be talking about my own experience working in a startup and in a bigger company as an engineer, and how you can make a decision of which kind of company you want to or you would like to work in, and what is it like actually to work in a startup and in a bigger company. Then I'll be talking about how to actually decide whether you want to work in engineering and implementation or research. Then I'll also give you a short overview of unconventional career options like freelancing and consulting, which you can also expect to work in if you have the right skills in robotics and artificial intelligence. And at the same time, I strongly believe that there's a need for more personalization or more personalized tools, frameworks, or processes that would help you identify your values, strengths, and the impact that you would like to have by means of your work, and I'd help you guide through those by providing you with the necessary tools. And then I would help you identify your own constraints that would help you identify and define your personalized roadmap for yourself. So who is this for? So this entire video, the ultimate career guide for roboticists or prospective AI engineers or researchers, is targeted towards bachelor's or master's students in engineering, in any engineering domain, or if you're a working professional in mechanical engineering, electronics engineering, or software engineering, and you want to make a transition to any of the following fields, whether it's robotics software engineering, computer vision engineering, machine learning engineering, data science, or any similar fields. So this video would be very helpful to you. So first I'll start with talking about my own personal career path. So I did my bachelor's in mechatronics or manufacturing process and automation engineering in NSIT, New Delhi, and in 2012. And after that, I worked as a mechanical design engineer at Honda for 2 years. And during my college, I was involved mostly in mechanical engineering projects such as building an off-road vehicle, human power vehicle challenge. And my bachelor's thesis was design and development of a motorcycle ambulance. So these were the kind of projects that I was involved in, not at all in programming, mainly mechanical design, mechanical engineering, powertrain, and similar areas. And in my work professionally as a mechanical design engineer, I've worked tremendously with CATIA, which is a design software similar to SolidWorks. And my primary role was design of several automotive components, design and development of automotive components. So overall, my profile was just mechanical design during my time in India in my bachelor's degree, while I was doing my bachelor's and also while I was working. And then I decided to pursue a master's in robotic systems engineering. And this gave me an exposure to different subdomains in robotics and artificial intelligence. My decision to pursue a master's in robotics primarily had nothing to do with AI or machine learning. In fact, I didn't even know about any of these fields. My primary motivation was that because of my work in mechanical design, kinematics, and dynamics, I was very interested in mechanisms and mechanism design. And so I wanted to explore more, but it wasn't possible to do it as part of my full time job in India. So then I decided to pursue a master's in robotics, and the robotics, the institute that hosted this course basically had primary research as mechanisms, kinematics, and dynamics. So that was really interesting to me. So that's why I decided to pursue a master's in robotic systems from RWTH Aachen University in Germany. And during my time in Germany, then I had exposure to a lot of different subdomains in robotics and artificial intelligence. Prior to that, my exposure was limited to mechanical engineering or also electronics, automation, and similar domains. There was a subject called robotics in my bachelor's degree, but that was also very fundamental and talking mainly about just kinematics and dynamics. So during my studies, I studied computer vision, machine learning, and a lot of different subdomains in artificial intelligence, multi-body dynamics, and a lot of different things. And so it was very difficult for me to decide which subdomain I should choose, because now suddenly I was exposed to a lot of different fields about which I wasn't very familiar with. So then I slowly started getting more interested in computer vision and machine learning based on the subjects that were taught in the university. And then I got a working student position, which is a part time job in addition to your main studies that you can do in Germany. And there I got exposure, more professional exposure to ROS, which is robot operating system. And I was involved in visual navigation and SLAM for drone and using a real sense camera. And apart from that, I was also involved in a machine learning image segmentation project. So this gave me my first industrial exposure to computer vision, and this got me more interested in computer vision and machine learning and deep learning. And then after that, as part of the course, we had to do a mandatory internship. So luckily, I got an internship at a very good startup that develops cutting edge robotic technology that uses actually deep learning and computer vision for cutting edge robotic manipulation tasks. And there I've got exposure to simulation. I also work with ROS and Gazebo and other simulation frameworks such as PyBullet. And I also got exposure to using deep learning to segment objects for grasping. So that project was particularly very exciting to me. And in order to gain more exposure, at this point, I wasn't really sure whether I want to work in industry or do I want to go more into research. So I started getting more involved in a project work at one of the institutes that had to do with task planning, which is another category of robotics. And then after that, I did my master's thesis at one of the startups where I got exposure to deep reinforcement learning for robotic manipulation. So far, then I've been involved in deep learning, machine learning, computer vision, but primarily for robotic manipulation or navigation tasks. So this was what I was also interested in. And the transitions that I made were also because I was following my own interests and I was following the directions, following the areas that were actually very exciting to me. So, computer vision and machine learning. So, I had to make the decision of shifting from mechanisms and kinematics and dynamics to something that would offer me more opportunities in the future, but also was very exciting to me, like computer vision for robotic manipulation tasks. And then after that, I worked as a computer vision engineer for almost a year, where I was involved in anomaly detection. It was also some machine learning, but also conventional image processing using C++ and OpenCV. And now currently I work as a robotics researcher, where my task is using deep reinforcement learning also for manipulation and other tasks. So this is how my overall journey looks like. It's a lot of transitions, but this that was because I was trying to figure out what is it that I really find exciting and what are my real interests. So I worked. So in India, I was primarily involved in mechanical design, and then my interest was in mechanisms and kinematics and dynamics, and then I followed that, and then opened new opportunities for me that allowed me to explore more fields, and slowly I started defining my own niche. So let me break down my own journey and explain in detail how I arrived at these decisions, why I made those transitions, and what I learned from this experience. So I told you about all of these different experiences. As you can see, these are in a lot of different areas, not exactly entirely different, but still quite varied. So primarily, I've been involved in computer vision and deep learning for a lot of different projects, but uh, also for the role of robotic software engineer using ROS and other simulation platforms. Then more researchy roles involving task planning and deep reinforcement learning. So I've worked in startups applying deep reinforcement learning, and then I worked in research. Actually, this deep reinforcement learning uh, these deep reinforcement learning blocks that we see, these were also at a startup, but it was my master's thesis, so it was involved more in research. And then I worked as a computer vision engineer in a bigger company. So I have a variety of, so I have exposure to different categories of companies, like startups. What is it like working in a startup? What is it like working in a bigger established company? What is it like working purely in theoretical research and developing novel ideas and so on? So let me walk you through my decision making process now. So this is the framework that I have basically used. I've been following my interest in every step of the journey, and then I also leveraged the available opportunities that were there. So it's one thing to just try to follow your interests. It's another thing to also get opportunities that are aligned with your interests. So you have to also make use of the opportunities that you're available, and then make reevaluate your interests based on the opportunities that you get, and then you define your professional niche. So how was this process like? I'll walk you through it in detail now. So initially, my main interest when I just started studying manufacturing process and automation in NSIT was automotive design, powertrain systems, mechanisms, kinematics, and dynamics. So this I had an inclination to this based on the subjects that we learned, and I realized that there were some projects going on in my university. Luckily, there were a lot of different kinds of projects that students participated in, like Baha SAE, Human Powered Vehicle Challenge, and so on. So these were a few projects that I participated in. And then I also did my bachelor's thesis on design and development of a motorcycle ambulance. So that was again in the direction of mechanical design. So these opportunities essentially allowed me to then reevaluate my interest, and then also make it really concrete that yes, I'm interested in mechanisms and kinematics and dynamics, but I want to focus primarily on design and not just manufacturing or uh, plant related work. So I was more interested in mechanical design and using design softwares and calculations for mechanisms and kinematics dynamics than I was in manufacturing production line work. So then I defined my niche as, hey, I want to work in mechanical design engineering. And during my placements at NSIT, basically, I only applied for the companies that were into mechanical engineering or mechanical design. And luckily, then I got my placement. I got my first job out of university at Honda Research and Development, which was perfect for me because then I could, because there I had the opportunity to work actually in mechanical design. And then after that, after some time, I realized that the work that was there at this R&D was more development related and less researchy. So I wanted to dig deeper into the mathematics and calculations of kinematics and dynamics. I was also fascinated with the door lock mechanisms, which I got exposure to also as part of working in the company. So from there, I realized that yes, development and engineering is cool, and I like the mechanical design process, but I want to dig deeper. I want to maybe do research, but I wasn't really that exposed to research at that point. So I was like, okay, what can I do? Then I said, okay, let me define my niche as research and mechanism design, and then slowly I'll try to figure out whether or not this research thing is mainly for me or not. But I was getting really fascinated by mechanism design, especially because of the mechanisms involved in the automotive systems, especially door lock, but also windshield wiper and things like that. So then I started doing my masters again, following the same framework. I defined my interests as mechanisms, kinematics, and dynamics. And here, after learning some subjects, I also realized that hey, computer vision and machine learning are also really, really interesting. And then I thought, hey, mobile robots is maybe something that I can target. And then, of course, I have to get relevant professional opportunities. So I started applying for some part-time positions to get more exposure, and there I got exposure to working student position that allowed me to do visual navigation for drones using ROS, but also image segmentation using deep learning. And then I had to make the tough decision of actually evaluating whether or not I want to stick with mechanisms in kinematics and dynamics, because that is something that I could also do. So I realized that there are more job opportunities if I go in the computer vision and machine learning direction. And it's also more interesting to me because I started to get more involved in programming tasks as part of my university courses. So I thought, yes, this is something that I also enjoy, and I think it's time to make a decision that I want to go in computer vision and machine learning, but I also wanted to be associated with robotics, primarily mobile robots. So I defined my niche that hey, I would target to become a computer vision engineer. So this was literally the goal that I set. And of course, then I had to do an internship as part of my curriculum, and then my interest at this point was computer vision and machine learning, and and also mobile robots, and then making use of the relevant opportunities of internship at this startup. I was involved in computer vision and deep learning for robotic manipulation. It was pick and place application task that I was involved in. I was also involved in robot control using ROS and Gazebo. So this gave me a lot of exposure, and this was at a startup basically. And then I reevaluated that hey, my interests are actually, I have to narrow it down. I cannot do everything. So maybe computer vision and machine learning, but I like the robotic manipulation application more than drones or mobile robots, because it's still in a way I'm associated with the complex kinematics involved with the robotic arm, but I'm primarily working with computer vision and machine learning. So then I defined my niche as computer vision and machine learning for robotics applications. Note that my working student position was at a bigger company and my internship was at a startup. And in the startup, I was involved in more cutting edge, state of the art technology than I was in the bigger company. So I got exposure to both. Hey, yeah, I like working in a startup, and I like also how the systems and structures work in a bigger company. So at this point, then I had exposure to both of these, and then I thought, okay, let me take up another project just to gain more exposure to what are the different fields, because till now then I was exposed to robotic manipulation, maybe some mobile robots, and um, mainly computer vision and machine learning. So these kinds of things, and I wanted to see other fields of AI. So there's this subdomain of AI called task planning that I got exposure to, that I also thought was very interesting, and it was more researchy, and it's also used in industries for planning of several actions for robotics tasks. But what I was involved in was mainly research. So then I was exploring, hey, do I want to work as an engineer or in research? So there I realized that research has more freedom, and I like to play with creative ideas and come up with more creative solutions to open-ended problems. So I thought, yes, research is also something that is interesting to me. And as part of my master's program, I had to do a research my master's thesis anyway, which is generally more researchy. So at that point, then my interest, my niche is defined as computer vision and machine learning for robotic manipulation, and my thesis was then also in this domain, which was very interesting to me. So deep reinforcement learning for robotic manipulation, and I was also a working student, and I was doing computer vision and deep learning for robotic manipulation essentially. And I also got exposure to reinforcement learning, deep reinforcement learning, which is generally not used in industries because it's still the results are not as good enough to be employed directly in a robotic pipeline in the industry. So it was more researchy, and that gave me clarity that yes, I want to work in robotics research using computer vision and machine learning. So deep learning, reinforcement learning are part of machine learning, and deep reinforcement is then a special category of reinforcement learning that uses deep neural networks. So this was my niche that I defined, and my interest was more or less research. But then I got the opportunity to work as a computer vision engineer full time, and I had to then uh, re-evaluate my interests, and I said, hey, yeah, computer vision is interesting to me. But again, I faced the similar problem that I was having when I was working as a mechanical design engineer in India. I was enjoying the work. It was implementation, C++, computer vision, anomaly detection. But I realized, hey, I want to dig deeper, and I want to understand the concepts really deeply mathematically. And this is where I then decided that, hey, um, I would probably enjoy research more. And based on my master's thesis and my research experience and the variety of different things that I did, I got an opportunity to work in research. And currently, I'm working as a researcher in deep reinforcement learning for robotic manipulation. And I'm also exposed to other machine learning areas. So the research here is basically at the intersection of machine learning and robotics. So having worked there, I also realized that I really enjoy reading research papers, understanding them and implementing them, building things from scratch, playing with new ideas and so on, which is something that you can only get exposure to in research, or to a certain extent as a research engineer in some companies. So this was my breakdown. Hope this is useful. Now let's talk about the different domains in robotics and AI. I'll not go into too much detail. I have a separate video where I talk about this breakdown of different subdomains in robotics and AI in a lot more detail. So essentially, robotics is at the intersection of mechanical engineering, electronics engineering, and computer science, and AI can be categorized as a subfield of computer science. So these are all of the subfields of robotics specifically. We have mechanical design, modeling and simulation, kinematics and dynamics and manufacturing in the mechanical engineering domain. And then we also have controller design, sensors and actuation, communication, power, electronics. These are the subfields in the electronics domain that are used in robots. And then we have software engineering, robotic software engineering, artificial intelligence, communications and networking, data science as part of computer science. And then we also have fields at the intersection of mechanical engineering and electronics, like mechatronics and control systems, and computer aided design, computer aided engineering, computer aided manufacturing at the intersection of mechanical engineering and computer science, and then electronics engineering. And at the intersection of electronics engineering and computer science, we also have internet of things, cyber physical systems, and embedded systems. Again, this thing is covered in more detail in my video titled Top Subfields in Robotics and AI. Now, talking about AI, some subfields are, let's say, machine learning, natural language processing, knowledge representation and reasoning, planning and decision making, perception. And these include supervised learning, unsupervised learning, reinforcement learning, deep learning, evolutionary computation, and then syntax, semantics, pragmatics in the NLP domain, and computer vision, speech recognition and haptics in the perception domain, and then ontologies, logical representation, uncertainty, reasoning in the knowledge representation and reasoning domain. And then in planning and decision making, we have classical planning, heuristic search planning, and rule based representation. So these are just names. You can look for what is going on in these fields in more detail, or watch the video titled Top Subfields in Robotics and AI. Now, these are a lot of different fields, as we have seen. And in robotics and AI, you cannot really know everything. Robotics is vast, and using AI for robotics, it's a lot of different fields that exist. So you need to define your own niche or a very narrow topic that you're interested in, and work professionally, go really deep into it and master that thing in order to be valued, in order so that your skills are valued by the industry. So this is a framework that you can use to define your niche, and it can be applicable to basically any career path, but we are talking here in terms of robotics and AI. So we know that there are so many different fields in robotics and AI. You have to try out different things. You have to find the topics, the projects, and the technology stack that you find most interesting. You have to identify your strengths and values. Hey, what is it that I'm good at? What do I really enjoy more? Do I enjoy creative problem solving more? Do I enjoy mechanical design more? Do I want to work with hardware? Do I like programming more? You have to identify your strengths, your values. What are the topics, projects, and technology stack that you're most interested in? And at the same time, you have to also recognize the impact that your work is having. Yes, knowing what you're interested in and having an interesting job that is aligned with your strengths, that you're good at and that you like doing, is good. But at the same time, if you connect it with uh, a real world impact, then you would be really inspired to work. Because hey, if you work in, let's say, a startup that is building mobile robots for homes, and you say, hey, I like robotic software development, and what I'm building is also going to be used by people, and this is something that is going to have a positive impact on the world. And then this is something that would really keep you motivated, and you would stay in the field for long if you're inspired in that way. And also, of course, you have to be paid for that, because money is important. So you have to make sure that the your areas of interest that align with your strengths also have enough job opportunities. So one another framework that you can use to decide which field you're really interested in is to think about the tasks that really bring you into flow state. So a flow state is a state that you uh, reach when you have a perfect balance between your own skills and the challenge of the task. So if your task is very challenging, very difficult, and your skills are very low, so for example, initially maybe your programming skills are not very good, and you take up a very challenging, difficult problem, then of course you would feel anxious, stressed, and you would not be able to enjoy that task very much. But if you take up a very simple task that is in alignment with your skills, which are low at this point, then you would start enjoying that task more. So you would experience something called flow. And you can try out a lot of different tasks. It's also a matter of experimentation and seeing what are the things that you really enjoy doing. Like maybe it's designing mechanical systems, maybe it's playing with hardware, maybe it's programming, maybe it's reading research papers, maybe it's implementing research papers, writing research papers. So you can experiment with a lot of different tasks and try to observe, hey, what are the things that really bring me enjoyment and bring me into this flow state. And this is a framework that you can also adopt to learn different subdomains in robotics and AI, because you can start at any skill level, take up a very easy task, and then slowly, as your skills increase, you can increase the difficulty of the challenge or the difficulty of the task, and you can make sure that you are in flow state regardless of where you are, regardless of what your current skill set is. And this applies to the topics, projects, and technology stack of your interest. So let me also then walk you through the learning framework that you can adopt in order to define your niche. This learning framework is for absolute beginners, it's project based, it's personalized, and it's in three phases. So I mentioned that you need to define your niche, but robotics is very interdisciplinary, so you need to have a certain level of interdisciplinary knowledge. So the top of this T represents a broad level of understanding of different fields in robotics and AI. It doesn't have to be all the fields, but it has to be at least a few fields that you're knowledgeable about on a superficial level, that you know, hey, what is it like working in this field, so you can communicate and collaborate with other team members. And then of course you have to develop a niche expertise. And the framework that you can adopt to start learning, I would not go into too much detail explaining this framework, because this is part of the video titled the complete roadmap to learn robotics and AI in 2023, and you can have a look at this video which explains it in more detail. So essentially, to summarize it, it has phases of learning. Initially, when you're starting about, you should be intrinsically motivated, so you have to follow your interest, you have to follow your own curiosity and explore different topics that you're interested in, and build that broad top base of this T, which is driven by your curiosity. And then you have to explore, you have to also deliberately explore different domains so that you have an interdisciplinary set of knowledge. And then after that, uh, you try to aim for progressive mastery in the field of your interest. So in order to do that, you have to list three projects in the ascending order of difficulty. Take up three projects of your own interest. These do not have to be uh, searched online. You have to decide what is it that you're really interested in, and write down, hey, I want to build a mobile robot, or I'm really interested in image segmentation. Just like list some projects based on out of your own curiosity. And then after that, some in three specific domains that you're really interested in, define five projects in each of these subdomains from easiest to hard. And this will then allow you to explore different domains. And the idea is that you do the easiest project in each of these subdomains, each of these three domains, so you get a certain level of exposure but not in too much depth. So you see, hey, this is how reinforcement learning cart pole problem is solved, let's say. Or hey, this is how a simple visual slam task is done, or this is how simple task planning task is done, this is how a simple NLP project can be built. But then you decide your own niche based on this exposure of curiosity driven projects and also domain driven projects. And once you do that, then you take up five different projects or more if you can, to build really niche expertise in one subdomain. Again, this is covered in more detail in my video titled the complete robotics roadmap for 2023. So now let's look at some career paths in robotics. You can, if you start applying for jobs, you will see that you can work in mechanical engineering, electronics engineering, software engineering, mechatronics or automation engineer, embedded software engineer, or also some semi-technical fields like technical sales engineer. Sales engineer is also an emerging field, and application engineer. And then also research engineer is something that has been coming up a lot these days because robotics and AI research is progressing at such a fast pace. And then companies want someone to read the research papers, have a deeper understanding, and but then implement those. So it's a research engineer role. And then if you want to dig deep in research and work as a research scientist, then you would need to be publishing papers and contributing to the state of the art in machine learning algorithms or robotics technology. So let's have a look at some of these job profiles. As a mechanical design engineer, you would work with CAD CAM, finite element analysis, computer aided engineering tools, and design for manufacturability. You can work as a quality assurance engineer and work, and you would need to understand geometric dimensioning and tolerancing methodology, statistical process control, root cause analysis, and failure mode and effect analysis. Then you can also work as a manufacturing engineer using Six Sigma, process optimization, and supply chain management, lean manufacturing. So these are the keywords that you can look into if you are exploring manufacturing engineering jobs. Then another profile similar to design is the product development engineer, but apart from product design and prototyping, it also involves cost analysis, quality control, understanding of manufacturing process and material selection, and project management. For electronics engineer, here are some job profiles that you can consider. These are electronics hardware engineer, that would involve FPGA, field programmable gate array, analog and digital electronics, design of PCBs, and power electronics, to name a few. As an embedded systems engineer, you would work with embedded C, C++ engineer. In some cases, it can also be defined as embedded software engineer. But primarily, you would be involved in real-time operating system. You will work with real-time operating system, software, hardware integration. You would need to have knowledge about communication protocols and experience with hardware in the loop. Now coming about talking about the ones that uh, are most in demand these days in the software domain, robotics software engineer. So as a robotics software engineer, you need to know both C++ and Python. Primarily C++ because as a robotic software engineer, you work with hardware and you're involved with low level tasks. So you have to work with real robotic systems and hardware such as cameras, sensors, and so on. You have to have knowledge of software architecture, knowledge about control loops and kinematics and dynamics, and you have to be familiar with software engineering practices such as version control systems like Git and agile development methodologies. uh, these are applicable for all of the software engineering roles that I'll be talking about. You can work also as a robotic software engineer in the navigation domain. There you would be specifically working in navigation and SLAM and using ROS packages in those domains and work with Python and C++. Expect to use also sensor fusion and robotics control, familiar with cameras and laser scanners or IMUs. Linux is, of course, something that you would need to work with in any of the software engineer roles here. Then, as a motion planning engineer, again, you need to know C++ and Python is C++ and Python. I would recommend that you, as a beginner, you can start with Python. And as a robotic software engineer, C++ is also very important. So you have to eventually switch to C++. Although for machine learning, I think Python is more than enough. So for motion planning engineer, path optimization, trajectory generation, and kinematics, motion planning algorithms, all these kinds of things. For data scientists, Python and R are more required. And robotics control is not required. I think this has been accidentally added. So data analysis, statistical modeling, proficiency in using NumPy, Pandas, SciPy, the popular packages, and scikit-learn, TensorFlow, PyTorch, all these frameworks, right? So, and you have to have knowledge of data visualization tools like Tableau, and others, and you have to be familiar with, again, the software engineering practices, Git, and agile development frameworks. Now, computer vision engineer, depending on whether you're using hardware or cameras or not, if you're working with hardware and cameras or lasers or scanners, 3D scanners, and so on, you would probably be working with C++. But if you're just working on image data and uh, cameras are not primarily involved, and maybe Python is also sufficient. But generally, as a computer vision engineer, C++ is also very important. Also, the knowledge of machine learning is um, very much needed as a computer vision engineer these days. You would work with point cloud processing, object recognition, and things like that. And as a machine learning engineer, of course, you have to be familiar with the frameworks such as PyTorch, TensorFlow. You have to understand how neural networks work, what are the popular machine learning algorithms, what is deep learning, how to play with data, data augmentation, data transformation, what are the libraries that are used, pandas, numpy, etc. So these are some of the profiles. And then robotics software architect is another one where you would be mostly involved with robotics middleware, system integration, and so on. And then there's cloud or DevOps developer, where you can expect to work with, again, TensorFlow, PyTorch, but also open source data transformation, analytics, and data visualization tools, and Hadoop or Spark, and neural networks and data transformation. So these are just to give you an overview of different fields to gain an accurate estimate of what are the skills, what are the software packages, what are the tools that are required, whether there's a hardware experience that is required. It's best to go on LinkedIn or on the websites of official websites of companies, and actually look at the job section and try to look at the job description and see what are the skills that they're required, and start focusing and working on those skills. So if you're looking for names of some popular robotics startups in Germany that use artificial intelligence like computer vision, machine learning, or NLP for robotics applications, then you can watch my video on top 10 most cutting edge German startups at Automatica 2022 that develop AI for robotics. You can also read the article on the website learnroboticsandai.com. So I want to give you an example of a couple of job profiles that are there, let's say in Germany, but also overall in the world. The job descriptions would be more or less same. So this is a robotics software engineer for perception and manipulation in one of the popular German startups, and they expect you to have a master's or PhD in robotics, CS, or electrical or mechanical or a comparable field of study, and they expect you to write production ready code in both C++ and Python. So that's why for robotics software engineering roles, both C++ and Python are important, and computer vision and image processing in knowledge is also asked for in this case. You have to have they are looking for experience in ROS and experience in machine learning. So this is an example of a profile that requires very much an interdisciplinary understanding of different things like computer vision, machine learning, and image processing, but also then ROS and integration of these different pipelines into a ROS framework, and both C++ and Python. So this is something that you can expect. And another one which is slightly different is embedded software engineer. They require Git, software packaging, uh, version control, knowledge of software testing. C++ is required in this case, and embedded targets and microcontroller architecture, peripherals, and knowledge of sensors, sensor integration and communication, and performance of code reviews and writing software tests. So these are the things that you can expect. Again, you have to make a list of the companies that you're really interested in, then make a list of the skills that are common, the tools that are common, the programming languages that they expect, and start working on improving those, because this is what would be required of you when you start working in these companies, let's say. So how do you choose a career path? You have to begin with the end in mind. You have to first decide which are the companies, which are the kind of companies that I enjoy working in, and you have to do mini projects that make use of the technology stack that these companies are using. So if you are more interested in robotics software engineering roles and you see that everyone requires C++ and ROS, then do mini projects that involve C++ and ROS. And you have to identify and analyze different ongoing projects that are there, and you have to choose the ones that align. So to make it a bit formalized or explain it in a more simpler step-by-step manner, make a list of the topics that you find interesting, make a list of the companies in your area that are working on the topics that you're interested in, and go to the official website and start looking for job openings, or find people on LinkedIn who are working in these companies and look at their profiles and look at the technical tools and skill sets, and find projects online that allow you to develop those skills. And based on that, define your own personalized project based curriculum. So let's talk about whether to work in a software, in a startup, or an established company. If you say, hey, I want to work in engineering, I like implementation and programming more, should you work in a startup? Should you work in an established company? So one thing you can expect if you want to work in a startup is that you would most likely be working on cutting edge technology, and you most likely working on state of the art tools, working with state of the art tools, right? So it depends whether you want to work in a startup or in a bigger company. It depends on what you value most. So that's why this whole thing is very personalized. So you have to spend time and think for yourself, what is it that you really want to do? What is it that you value the most? If you value learning and growth the most, then maybe a startup is the best suited for you. And or maybe you find a bigger company that is all that allows you to learn and grow more as well. Maybe you value impact more, maybe you value personal responsibility more, maybe you think that mentorship and guidance is something that you need, and this is something that you would look for if you want to work in a company. Maybe you don't want to hustle and grind and work too much, maybe you want to have a work life balance, so you can look for a company that offers you that. And maybe you want to work on innovation and innovative technology, maybe you want to look for company that is more stable, that allows you to stay at the position for a long run, so that you can learn things at your own pace and do things of your interest there, and explore different things. Maybe you want to explore different resources. So what is it that you value the most? And then you have to decide, then you have to have an understanding of what is it like working in a startup, and what is it like working in an established company, and say, these are my values. I fit best in a startup. I would perform the best in an established company. So you have to make that decision. So in a startup, for example, it's typically a smaller company with fewer than 50 employees. Sometimes the companies with 100 employees are also startup, also called startup. So it depends how we define it. And then an established company often has thousands of employees. A startup has flat hierarchy, it's less formal, whereas an established company has more structure. Roles are more flexible and may involve multiple roles and responsibilities in a startup. So if you are more creative and interdisciplinary, you like teamwork, and teamwork would be important in both the cases. But if you like to get involved in different kinds of things, you would probably like working in a startup better. If you want to have an expertise in a domain and go really deeper into it, then a specialized role is valued more in a bigger company. You have to be quick at making engineering decisions in a startup. In a established company, because they are well established systems, so the decision making process can be slower, but you learn systems. If you value stability and structure, then an established company is for you. If you like to move fast and break things, then a startup is for you. Startups often also have limited resources and funding, so if this is something that you are okay with, then you can go for a startup, whereas an established company also can offer you more perks. And in a startup, there's of course more potential for innovation and creativity. And established technology tries to maintain existing systems, structure, and technologies. And there's more opportunities for career growth, career advancement in established company. You can also grow very quickly in a startup if you contribute significantly. There's of course a risk of failure and job stability. What if the startup fails, or what if they do not need more people? So this is something that you have to keep in mind. Established companies often have enough resources to offer you job security and stability. But the disadvantage of startup is that you often require working long hours, and you would have to commit fully to it. Whereas in an established company, you have better work-life balance. You can have a more significant impact in a startup. The impact may be slower in an established company, but it's also very widespread. So both have their own impacts. Depends on how you want to be impactful, in what way you want to be impactful. Some compensation benefits is that startups may offer stocks and equity. Established company may offer you bonuses and compensation package. So based on these, you can decide for yourself what is it that you like. You have to choose based on your personal values, and you have to get experience in a startup and also in an established company to see, hey, yeah, this is something that fits more with my personality and the kind of things that I want to do. So you can make a decision based on that. So create a list of your top three values. What is it that you value the most? Do you value learning and growth the most? Do you value stability? Do you value job security? Do you value teamwork and collaboration? And based on that, you can, and then after that, of course, you have to try to be associated with the startup and try to work in a established company, get a part-time role or a working student or internship role, and choose your path based on the values and work experience. Alternatively, you can also talk to people in startups and bigger companies, and just by talking, you can get a sense of what is it that you would expect, because it might not always be possible to get exposure both to a startup and to an established company. So you can leverage the experience of other people by talking to them and make your own decisions. So then after you have made a decision that, hey, I like to work as in a bigger company or a startup, another thing that you might want to consider is that um, do you enjoy research work more, or do you enjoy engineering work more, or do you want to work in industry or in academia more? And there are several factors that you can um consider in choosing whether you want to work in engineering or research. That is, um, whether you like practical implementation based problem solving, whether you value skill development, tangible product development, tangible system development, teamwork and collaboration, or independent work, deep understanding of theory, pushing the boundary of knowledge, and you like creative ideas more. So what is it that you like? You have to spend some time asking it. So again, there's a mistake here. These are the factors not for choosing the perfect company size, but for helping you to decide whether you want to work in engineering or research. So here's, let's say, a research scientist role that I randomly picked, and it requires a master's degree. Generally, for a research scientist role, you require a PhD. But sometimes, if you have good publications, they can also master's roles might also be sufficient. So, but you have to have relevant experience in one very specific narrow domain. As an engineer in industry, you can work as an engineer or as a research scientist. For a research scientist, you need to have research experience and have lots of publications. And as an engineer, you have to have really good programming or technical skills. And you have to be driven by problem solving and practical applications. Whereas a research scientist in industry or academia enjoys exploring new ideas, has a really deep understanding of technical concepts, and likes pushing the boundaries of knowledge and coming up with new ideas. So it's more lateral thinking, and engineering is more logical thinking. Although, of course, there's both these modes of thinking involved in engineering and research. So, do you want to focus on designing and building real world solutions, or do you want to delve deeper into theoretical concepts, conduct experiments, and explore new frontiers? So, what is it that you want to do? Do you want to apply established scientific principles to tangible products, or do you want to expand the knowledge and understanding within a field? Do you want to work in multidisciplinary teams and collaborate, or do you want to um, work in writing research papers and write them independently or in collaboration with other researchers? Do you prioritize practicality, efficiency, and effectiveness in your work? Then working in an industry is for you. If you prioritize exploration and you are very curious, you value intellectual curiosity and you value innovation and new ideas, academia or research path in academia or industry is for you. Okay, so, how do you choose between engineering and research? You have to identify your archetype. You have to define, you have to really think about it. Am I a researcher or an engineer? Of course, you can be both, but what is it that you enjoy doing more? You have to identify it, and then you have to try to get experience in academia, some part time or internship position, and then also in a company and see the contrast for yourself. Alternatively, again, you can talk to people in research and also in companies to get that exposure and choose a path based on that. So maybe you like to take more risks, and maybe you say, hey, yes, I like these paths of engineering, research, and deciding between startups and bigger companies and so on. But maybe I want to have more freedom in the kind of projects that I do, because in a company you're restricted by the kind of projects that the company is working on. And maybe you want to have that flexibility. So depending on uh, if you have certain skills and if you have that inclination, you can take an unconventional path. If you're really passionate towards innovating novel solutions, if you want to build a diverse skill set and want to utilize that, if you want to have a really bigger impact and um, you're not satisfied with the impact that you can have as an employee in a bigger company or even in a startup and so on, and if you value autonomy and independent work more, uh, whether or not you value work life balance, whether or not you value continuous learning and growth, based on these factors you would have to make a decision, if and whether or not you want to take an unconventional path or you want to follow some of the paths that we've already discussed. So this opens the door. If you want to take more risks, this opens the door to more self-employment opportunities. Like if you're highly risk taking individual, then you can go for entrepreneurship. And if you're driven by creating unique innovative solutions that have economic benefits, entrepreneurship is for you. And if you like to have independent decisions and you want to have impact by means of your decision and you want to have that independence, you have to have a proficiency in various areas if you want to build a startup or you want to start your own company. And work life balance would of course be a bit challenging because it requires a lot of effort, but you have the freedom and the independence, so you can be more flexible in that area. And then you can also use your expertise. You can develop a deep understanding in one field and develop that skill set and offer consultancy and expert advice for innovation. You if you Of course, the desire for autonomy is, if you have a desire for autonomy, you have the freedom to choose different clients and your own schedule. So this is also something that is of importance, that is you can consider. And for consultancy, however, you have to have a deep knowledge in a few domains, and proficiency in various areas is more of significance for an entrepreneur, let's say. If you value work life balance more, then um you would of course have more control over your schedule and workload, because you're also working independently, right? And there's potential for work life balance basically all in all the three directions: entrepreneurship, consultancy, and freelancing. In freelancing, you can work on a different a diverse set of projects, and you have flexibility and independence in choosing the kind of projects that you find the most interesting. So if you're someone who likes to work on different kinds of projects, maybe working in a company might not give you that exposure, because a company is focused, let's say, towards building one or a few products, right? So you can get that diversity of working, let's say, in augmented reality based project that uses computer vision for one project, and then computer vision for segmentation for another project. So you can have that flexibility. And you if you like offering unique and creative solutions, and you like working independently, so these are the factors that you can consider if you are exploring some self-employment options. Impact wise, of course, entrepreneurship is the most risky, and it also would offer the most lasting impact by means of your products. You have to, if you like learning, you have to learn a lot about different kinds of things, about also teams, building teams, and also about businesses, how businesses work, but also about the technology, the robotics and AI technology that you would like to do your startup or bigger or build a company or business in. Um, there is an opportunity to scale and business and achieve massive success. So there's a high risk, high reward kind of a situation here. For consultancy, the impact may not be as significant as compared to an entrepreneurship, of course, but you can drive positive changes within organizations, and you can also continuously learn and stay updated with industry trends. There is a potential for career growth and high income. For freelancing, you can help clients achieve their objectives, and this is the impact. There's something that gives you satisfaction. You can go for the freelancer route, and you also get the opportunity to continuously learn. But of course, as a freelancer, there's also a lot of competition, so you have to take that into account. There's potential for reputation and earning income growth. You have your own schedule, you have your own time. You are essentially selling your time as a freelancer and as a consultant. So you can, the more work that you can get in the time that you have, the more money you can make. Whereas in entrepreneurship, as an entrepreneur, you would be selling your products or service and not your time. So you have the potential to earn a lot more money. But of course, this involves taking risks, and you also have the potential to have a more uh, significant impact. Building a robotics company, if you want to build a hardware one, it's of course very challenging, and it doesn't have to be. You can build a software based startup or a company, or an education based company if you're interested in that. So choosing between these options, of course, you have to. The number one criteria is what is your risk taking tolerance. If you have a high risk taking tolerance, you should go, and you think you can handle financial uncertainty and failure, you should go for entrepreneurship route. That's a very rare path to choose because it's very difficult. And then um, if you like to take risks but slightly less, than medium risk is you should go. If you take medium risks, then you can go for consultancy. Or if you So freelancing would offer you the lowest risk, although of course you have to consistently search for jobs. So there's also this risk of having no income for a few months and then a lot of income for some months. So you have to choose between these paths based on your risk tolerance. Now, all of these things sound very good. All of these things sound very good, but you have to also make sure that you understand yourself. And what I mean by that, you have to understand what is it that you value the most, what are your strengths, what are your interests, what are the constraints and life situation that you're in, and based on that, make a decision that, hey, I think I would like to work in a startup as a robotics software engineer, or hey, I would like to build a robotics startup, or hey, I would like to work in research and understand and contribute to deep theoretical understanding of technical ideas in machine learning. So do you value learning? Do you value growth? Do you value stability? What are your strengths? Are you really mathematically strong? Are you really good at theory? Are you really good at programming and building solutions really quickly? Are you interested more in research and theoretical concept understanding and theoretical and ideas, or are you more interested in presentation, or are you more interested in implementation? Where is it that you're currently located? Your location would also restrict your opportunities, so make sure to take that into consideration. Your finances, family, and societal constraints that you have to think about that. So here's a list of a few values. What I want you to do is you just maybe pause the video, or you watch the video completely and come back to this and try to select the top three values based on this. Do you value learning the most? Do you want to constantly learn new things and that is what gives you satisfaction? Do you value um, impact? Do you value impact that your work has? Do you value independent work? Do you value stability, innovation, collaboration, creativity, originality, excellence, efficiency, growth, and spontaneity? So based on this, you can start selecting your top three values or top five values, and this would give you an understanding of what kind of things that you want to do. What are your strengths? You have to be very honest with yourself in this stage. Are you really good at systems thinking? Are you really good at teamwork? Are you good at debugging? Are you good at programming from scratch? Are you good at lateral thinking, creative thinking, logical thinking? Are you are you excellent at hardware design and playing with real world systems, networking and collaboration, or people skills? Are you good with autonomy or um, working independently? What are your interests based on the projects that you do, based on interaction with other people, based on the subjects that you would study, or courses that you would take online, or the projects that you would do based out of your own interest? You can decide uh, what is your what is it that you like doing the most and define your niche based on that. Could be manipulation, navigation, mechanics, planning, control, computer vision, deep learning, reinforcement learning, knowledge representation, electronics. Take a look at the different subfields in robotics and AI. Go back to this previous slides where I talk about the different subdomains in robotics and AI, and try to select the ones that interest you the most. Of course, try to do mini projects and follow the learning framework that I mentioned before. This will give you a good way of analyzing your interest. Constraints: take into account your location constraints. Maybe you're in India and you cannot go to another country. Maybe you're in US and Germany and you have more opportunities. Maybe you're in Australia and you have certain set of robotics applications there. So take into account location and how you can fit your own interests and find a job in that location. Take into account your financial constraints, and is it can you go for a master's and get a formal education or not, or can you just take up online courses, or can you just do really good relevant projects, build a portfolio and apply for jobs? Can you Are there societal, familial, health related constraints? Are your grades not enough to get you a job or go for a master's? Are your academic requirements not fulfilled? Are you from a totally non engineering background? So you have to take all of these constraints into account. And then you have to identify the impact. So this is the thing that nobody talks about, of course. You have to identify your interests, and talking about the ikigai framework, you of course need to work on the things that you like and that you're good at, but also what is the impact that you want to have by means of your work. As an engineer, you would be designing and developing robotic systems or AI systems and ensuring that they have good functionality. An example of this could be creating robots that assist in healthcare and improve patient care. As a research scientist, you would be involved in cutting edge research in robotics and pushing the state of the art in knowledge and innovation. Could involve designing new algorithms, publishing papers talking about new algorithms or ideas in machine learning, or to improve robot perception and decision making. As an entrepreneur, your task would be to lead and create robotics focused ventures driving economic growth. You can found a startup that develops robots for agricultural automation, as an example. As a freelancer or consultant, you can provide specialized robotic services to various clients. You can solve unique challenges, and an example of this is consulting on the design and implementation of industrial robots. So this is how you can decide what you want to do. Now you have to make a personalized plan or curriculum for yourself, and the curriculum has to be goal oriented based on these individual needs. It has to be flexible and adaptable and not rigid, because your life situations, your interests change. So you have to take those things into account, take the constraints into account, take your values and strengths into account, and learn practical real world skills. And take these constraints that I mentioned into account very seriously, because even if you identify your values, interests, and um, strengths and everything, and the impact that you want to have, but if you cannot physically relocate to a place where you have more opportunities, then you have to think about it, that hey, I have to stay in this country, let's say, these are the kind of jobs and this is the best that I can find here. Or you can say, hey, yeah, I have a full-time job and I can explore my own interests in my free time, and there's nothing wrong with that. You do have Saturdays and Sundays and additional time after a full-time job, and you can just explore your own interests if you um, cannot relocate, or if you cannot relocate to another country due to, or if you cannot go for a master's due to financial constraints, maybe you can find a job directly and learn things, build projects on your own, and just apply directly to other countries. So this is also a possibility. And as an example, I would like to give you case study of a client that had a counseling session with me, where um he had a few financial constraints. He currently works as a full stack software developer in India, and he did his BTech in IT from a good college. And he currently knows C++, Python, and Linux. So that was already an advantage for him. But his constraints were, he cannot pursue masters abroad due to financial constraints. He has plenty of time. He has the weekends with him. He has time on the weekdays after work, but he doesn't want to relocate to another country for a master's, but for a job he can. I liked his mindset. He was very motivated and ready to take action, and the action, though said he needed proper guidance, and he was willing to spend 2 hours daily and 3 to 5 hours on weekends. His interests are primarily robotics, computer vision, and machine learning. So he knew exactly what he wanted to do. He wanted to work in as a robotics software engineer. He knew C++ and Python, so his path is not that complicated in this case. So he did some online courses, machine learning and deep learning courses on Udemy, Coursera, the popular courses, and explored basic deep learning projects, did an internship in data science, did a mini project on a small scale autonomous vehicle using Arduino and Raspberry Pi. And here's how I defined his yearly and quarterly goals. So for him, it's really possible to secure a job as a robotic software engineer that pays more than the current job. For him, finances were very important. And so he wanted to secure a position that pays him equal or more than the current job, but in the robotic software engineering domain. So, based on the yearly goals, I split that into 4 quarters in the year. The first quarter would be dedicated to just defining a field of interest. Of course, even though he says that, hey, I want to do robotic software engineering, but he explored computer vision, machine learning, and deep learning, and he was a bit confused. So, the first quarter would be spent defining his field of interest and building. The next quarter would be involved building three small projects in three good projects in the chosen field of interest. And after that, 3 month after that, the quarter number three would be involved in defining a career path, and then last quarter is applying for jobs. So it's very much possible to make that transition on yourself if you are motivated enough. So let's see how quarter one looks like. So quarter one looks like, to define a field of interest, complete a ROS mini project, because he's very interested in robotics software. And then month two is complete a CV computer vision mini project, and then month three complete machine learning mini project. So these three projects in these 3 months, this would give him enough exposure. He doesn't need more exposure because he already has a certain level of clarity. And then after that, he can build two more projects in a chosen field. So he can take 1 month to really explore more, look at what are the different projects, and like search more theory, take up what some lectures, and really decide that, hey, I want to be in robotic software engineering, or I want to work in robotic software engineering but in navigation, or I want to work in robotic software engineering but in perception, or I want to work purely in machine learning. So quarter two would already give him the exposure to build his portfolio, and then quarter three would be spent building a portfolio. And at the same time, he was confused on whether he wants to go in with engineering or research. So third quarter is, of course, some of the there these are a lot of projects, so maybe some projects would not be completed, and then the rest of the month can be spent finishing the remaining part of some of the projects. And then 1 month can be spent doing a mini research project. And then after that, deciding between engineering or research. And the last quarter is then dedicated to job application. Month number 10 is building a portfolio, and then applying for jobs, and then preparing for job interviews. Buffer month, as I said, allows time for finishing incomplete projects. And then this is not enough. After that, you have to break down the monthly task into weekly goals and daily goals. So each monthly goal is split into four sub goals, one for each week. And you have to define daily habits and daily goals, and consistently spend a minimum of 1 hour on the weekdays and 4 hours on the weekends. So minimum of 13-hour work week, and then he would be able to make that transition. So this is the overall plan that I made. And of course, the projects that I have mentioned are complete a ROS mini project, complete a CV mini project, complete a an ML mini project. And the reason why I haven't given him a specific project, because the project has to be of his interest. And if you want to do a project, you have to do a project of your interest. You can do a ROS project, but maybe in your own area of interest. So make sure to follow your interest in this overall plan. So there's this is a more generalized plan from my video on the complete robotics roadmap for 2023, where if you have no idea what you want to do, what are the robotics fields that you're interested in, you can start with cultivating your mindset in the first year. So this is an entire yearly plan, starting from absolute scratch with no idea about anything in robotics and AI, and then exploring different subdomains of robotics and AI and defining your niche. So, mindset cultivation, identifying your why. Why do you want to learn robotics, first of all? Addressing any limiting learning beliefs that you have, defining your goals, finding accountability partner, setting the foundation, taking a foundational course on mathematics, ROS, Agile framework, or Git, and these kinds of things, and then learning the tools, leveraging your curiosity, defining the skill set, and doing some curiosity driven projects. I'm not going into too much detail of this plan. You can easily watch the video titled The Complete Robotics Roadmap that explains the whole robotics um, plan in a lot more detail. And then, as I mentioned, from the learning framework, there's domain driven exploration. You take up a few subdomains and take up more projects, evaluate your interests after that, and take up more and more projects in your own niche to gain progressive mastery, build portfolio, apply for jobs, and even after you have a job, continuously learn. As you see that robotics and AI are growing very fast, we have these generative models, large language models. There's advancements in robotics, chat GPT. All these kinds of things are advancing so quickly, so you have to make sure that you choose a niche and you also keep on learning and updating your knowledge and skill set continuously. Again, watch this video, and that's it. If you have some specific suggestions on any aspect of this entire video, or if you have any ideas on any suggestions on what is it that you would like to know, do you want to know about top resources in machine learning, computer vision, or top courses, or what are the kind of projects that you would want to build, or do you want me to share more about my own journey? What is it that you specifically like to learn about? Do you want more technical content? Do you want me to build more crash courses and projects? Just let me know what you're uh, interested in the comments below, and wish you all the best.